Let's look at a problem with a two-way table now. Let's say that there is a company that offers training to their employees, but they still have employees that are leaving the company, and they want to determine whether having given some staff training or not has affected whether they left the company or not. So let's say that we have given a two-way table here where we're given the figures of those people that are still employed, those people that left the company, and whether they were given training or not given training. And we're asked to find these two probabilities. Find the probability that a randomly selected employee did not leave the company given that the person had received training. So given that the person had received training, so we're just looking at this row, okay? That means that we now need to look at did not leave the company. So did not leave the company, and so they are still employed. So we've got to read this very carefully, otherwise they're going to catch us out. So it's 109 out of the 152. Okay, so I don't think that simplifies off the top of my head. No, and it doesn't. Okay, so then that would be the probability that we need. If we're asked to find the probability that a randomly selected employee did not leave the company given that the person had not received training, so given that they had not received training, okay, what's the probability that they did not leave the company? That means that they're still employed, and so that would be 60 out of the 104. Okay, and that fraction can be simplified down to 15 over 26. Okay, so really what I want to highlight here is that you need to read these questions very carefully to make sure they're not trying to trip you up, okay? But this is how conditional probability works with a two-way table.